Okay, today we're going to look at special right triangles, but to warm us up, we're going to look at the Pythagorean theorem. So as a reminder, the Pythagorean theorem says, hey, if you have a right triangle, so in a right triangle, right, a squared plus b squared equals c squared. So a, b, and c being the sides of the triangle, a, b being the two legs of the triangle, c being the hypotenuse, all three being the sides. Okay, so let's go ahead and do a couple examples. So it says solve for the missing side. So I think I'd always recognize, hey, what's C? So like across on the 90-degree angle is C. So something here you'd have 12 squared plus 16 squared equals C squared. So we're solving for C, we'd have 12 squared is 144, 16 squared is 256. So as we add these two together, we end up with 400 equals c squared, and we take the square root. C equals a nice even just 20. Notice here we're not worried about positive and negative in this case because we don't want a negative side length. Here C is 8, so we're solving either for A or B. Let's call it A. So a squared plus 4 squared equals 8 squared. So to get a all alone, we have 4 squared is 16, 8 squared is 64. Subtract 16 on both sides. We get a squared equals 48. Take the square root. A equals the square root of 48. If it asks for an exact answer, you're going to want to leave it in the square root format. You can simplify it if you want, right? We could say 48 breaks down to like 16 and 3. 16 breaks into 4 and 4. And right there, I've got a pair. If you broke it down further, you'd have two sets of 2, so 2 times 2 is 4. This becomes 4 squared is 3. So, just remember, if it ever asks for an exact answer, you're going to want a square root. Okay. There are other times where maybe it doesn't specify or it says round decimal places, like this next one, it has decimals in it. It'd be okay to write the decimal equivalent. So it says here, it says one leg of a triangle is 5.3. So maybe this is 5.3. And the hypotenuse is 7.2. So we want to find this other side. Always draw a picture. I think it helps to kind of visualize. So 5.3 squared. I guess I should do A, so that's how we usually start. Sorry. A squared plus 5.3 squared equals 7.2 squared. This one, they're not as nice numbers, so I would actually just like subtract 7.2 squared minus 5.3 squared on my calculator, because then it gives me just 23.75. So not as much to deal with. Take the square root of both sides. A equals 4.87 if I'm rounding. Okay, last but not least, this one, we're looking for C again. So we'd have 1 squared plus 1 squared plus 1 squared equals C squared. So we get 1 plus 1 equals C squared. 2 equals C squared, take the square root. C does equal the square root of 2. Okay. This is the relationship that I want to point out. So in this picture that we have right here, we actually have an isosceles triangle. So it means that these two angles are equal as well. And any isosceles triangle, right, the two legs are equal. That's the definition of isosceles. But the hypotenuse will always be the square root of 2 times the side lengths. So if I wanted to generalize that case, if I look at over here, an isosceles triangle, we'd have two sides. Let's call it A and A. This last side, if we want to think about C for a minute, we could say A squared plus A squared equals C squared, our hypotenuse. So if we're solving for our hypotenuse, A squared plus A squared is 2A squared equals C squared. Take the square root. And I think 2A squared may be easier for you to think about as 2 times A squared, which is then A times A. So notice you got a set of A's and a leftover 2. So that's the same as A square roots of 2 is equal to C. So this is a times the square root of 2. So you'll notice this relationship is true for any 45, 45, 90 or isosceles triangle. An isosceles right triangle, you will always have the two angles are 45 degrees. So we're going to use this idea as we solve for things down below. So for example, this first one gives you the hypotenuse, which in our picture is like the a times the square root of 2. So if our hypotenuse is 6 square roots of 2, that means the two sides, x and y, are each equal to 6. Okay, let's look at the next picture. This next picture tells us that one of the sides of the triangle is 5 square roots of 2. So it means, since it's isosceles, that x would also have to be 5 square roots of 2. So then, in essence, our value of a is like 5 square roots of 2 here. So the hypotenuse y would be 5 square roots of 2 times another square root of 2. You could do that in your calculator, or you should maybe know that square root of 2 times square root of 2 is just 2. 5 times 2 gives me 10. So y equals 10 here. Okay, next. This is a little trickier. They gave you 8 as the hypotenuse. So I maybe think about 8 equals a times the square root of 2. We want to find that value of a, because that's going to be the same as x in this picture. So once again, I'm getting this a just from this diagram up here, right? I'm just using this diagram, but just kind of those sides all have the same exact relationship. So to get a all alone, we can divide by the square root of 2. So a equals 8 divided by the square root of 2. Yes, you can simplify that further. I will not make you though. So x is 8 divided by the square root of 2. Okay. As we look at another triangle, this next triangle is a 30, 60, 90. So the trick here is they kind of start with an equilateral triangle, so it means each of the degrees are 60. And we're going to call the side lengths 2, so all the sides would be 2. They drop this line down the middle, called it altitude, so we know it makes a right angle. It splits the top, which is 60 in half, so we get 30 and 30. And it splits the bottom, so if a side length of 2, we'd have 1 and 1. We are going to focus on just like the right triangle for a minute. So if I redraw just that right triangle, this is a 60 degree. This is a right angle. This is 30. This side length is 2. This side length is 1. Let's solve for the missing side. So if I had like 1 squared plus b squared equals 2 squared, I'd have 1 plus b squared equals 4. B squared, and you subtract 1 from both sides, equals 3. Take the square root of both sides. B equals the square root of 3. So I made it nice and easy because I made it the side length of 1. But we chose just another variable. So in class, we chose the variable w. So the smallest side will always be across from the 30. So across from 30 is going to be our smallest side. Let's say we represent it with some random letter, like some numbers. So a letter to represent any number. So we use like w. Then the hypotenuse is always twice that length, so 2 times whatever w is. And the longer leg is always w times the square root of 3. That relationship will hold true for all the sides in any 30, 60, 90 degree triangle. Okay, so you'll notice here across from the 30 is the 14. So this is like w in my picture. Okay, so if this is like w, then y is 2 times w. So we would have 2 times 14. So we get 28. And then x is 14 times the square root of 3. Okay, I'm going to skip to 6 and then come back to the middle one. So this time they give you the hypotenuse. So they really have 6 as like 2w. So I solve for w, I divide both sides by 2. W equals 3. So that means my short leg, right, across from the 30 is the x, is 3 here. Which means y in this case is 3 times the square root of 3. Right, the longer leg is square root of 3 times that short leg. Okay, this one's a little bit trickier because here they give you the long leg, the side across from the 60. So 21 equals w times the square root of 3, right? It's like that side of the triangle. To solve for w, we're going to divide by the square root of 3. So w equals 21 divided by the square root of 3. And that should equal the short leg of your triangle. So here y equals 21 divided by the square root of 3. And then x should equal twice that amount. So 2 times 21 divided by the square root of 3. You can do that in your calculator if you want, but the square root of 3 is not going to come out super nicely, so basically just 2 times 21. So you get 42 square roots of 3. Okay, we got a few more. We're just kind of putting it all together. So this one, they give you, we got a 45, 45, 90, right? And they give you the hypotenuse. So this is like a square roots of 2, right? Remember? If you look at the diagram in the front. So a is like the number 4, so that means that x, your two legs of the triangle, would have to be 4. This side 2 would technically be 4 too, if that helps you. Okay, now they labeled the side across from 60, so that's the long leg. So then 4 is like w times the square root of 3. So we're going to divide by the square root of 3 on both sides. And then this side right here would be 4 divided by the square root of 3. But the hypotenuse is twice that, so twice times 4 over the square root of 3. So we end up with 8 divided by the square root of 3. Okay, this one they labeled WZ as 5. Since it's an isosceles triangle, this would also have to be 5. So WY is also 5. The hypotenuse is the square root of 2 times longer than that, so 5 square roots of 2. Okay, now let's look at the other triangle. The triangle on the left is a 30, 60, 90. We have the side across from the 30, so that's the short leg, which means the hypotenuse is 2 times 5, which is 10. So xy is 10. And then the long leg is 5 times the square root of 3, right? Square root of 3 times longer than the hypotenuse, so 5 square roots of 3. Okay, just based on the time we had in class, we skipped 9, so I'll go ahead and skip it here in these notes. But we did do 10. So we got a 28-foot ladder leaning against a wall that makes a 60-degree angle with the ground. So we got this ladder, and it's 28 feet. And with the ground, it makes 60 degrees. And you can kind of imagine there would be like a right angle there. And here we want to look how high does the ladder, how high up the wall does the ladder reach, right? Okay. Sorry, that picture here, I just wanted to make a little triangle a little clearer here. So 60 degrees, and then here. So here, we can use that relationship, right? So as we want to think about labeling these sides, 30, so we know the hypotenuse, which is twice the longer leg. So if 2w equals 28, divide both sides by 2, that means the shorter side, or w, is 14, which means the long leg is equal to 14 square roots of 3. So if we're answering the question, 14 square roots of 3, when you type in your calculator, you get 28 point something, but it says the nearest foot, so 28 feet would be how high? Sorry, 24. I apologize about that. We get 24 point something. So it reaches about 24 feet up the wall. Okay, good luck with your assignment.